Hi everyone, this is me Hassan and welcome to my channel Hassan Academy. So today we are going to discuss one more concept regarding alkyl halide. Okay, let's discuss three molecules. Let's take three molecules. One is 1,2-dichlorobenzene. One is 1,3-meta-dichlorobenzene, and another is para-dichlorobenzene. Yes, these three molecule I have given to you, and now I am asking the dipole moment. Okay, dipole moment. Dipole moment. What will be the dipole moment? And dipole moment final resultant mu is equal to mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. Yes, this is the dipole moment equation. If you give square here, this square root will eliminate. Now from here one thing you have to understand, this cos theta value. Okay, cos theta lesser is higher value. What I mean, cos 0 is 1. Okay, cos 180 is -1. Okay, so in between it will keep decreasing, it is not going to increase. Okay, so you can see here resultant this one, because chlorine and all they are ring deactivating group withdrawing, it will go this direction, it will go this direction, they are near, but here angle is increasing, and here you can say if this one this way, this one is this way, they are 180 degree of each other. Simply you remember, whenever you are talking about two group and their nature in the sense they are electron donating or electron withdrawing overall. Okay, some groups are there which are showing -I but +M also. Overall finally you have to go for which one is more, -I is more or +M is more. +M is more means you have to go for +M, that means donating. Now in case of halogen, you know that they has the ability to show -I inductive, and same time they have the ability to show little +M also. But overall which one is more? Overall withdrawing is more. Since overall withdrawing is more, so you have to consider them, they both are ring deactivating. Since their both nature is same, at that time you remember, lesser the theta, more the dipole moment. Okay, if their nature is opposite, one is donating, one is withdrawing, like in case of paranitrophenol, OH group is donating but nitro group is withdrawing, at that time also you have to you cannot simply follow the theta at that time. At that time you have to find out the resultant vector where it is going. Okay, because if you see at that time their theta, that they are 180 of each other, paranitrophenol I am talking about. Okay, but orthonitrophenol their theta is 60 degree, and paranitrophenol their theta is 180 degree. Even though theta is 180 degree, since their nature is opposite, so you cannot simply follow this formula. Okay, so at that time paranitrophenol is more, but here paranitrophenol, since they are para of each other, they are 0. Okay, hope you understand what I am trying to mean. Okay, so here who is the winner? Ortho is more, then meta, then para. Para is in fact it will be 0. So let's discuss some more molecule. Dipole moment. Dipole moment. Let's talk about methyl chloride. Yes, Cl will be more than methyl fluoride, and this one will be more than bromine. At last, CH3 iodine will come. Okay, so now you have to understand, when we go for that formula, mu equal to Q into D. This D is the distance from that center to the this side atom. Okay, distance. But this Q is charge. How much charge delta minus is produced? Suppose here also delta minus producing, here also delta minus producing. It's not mean that both delta minus is equal. Okay, suppose hydrogen and fluorine I am talking about, and hydrogen and chlorine I am talking about. Here delta minus, here delta minus. This delta minus is more powerful than this one, because fluorine is more electronegative than the chlorine one. Okay, hope you understand. So now you have to go for overall, where which one is the winner. In this case you have to see charge also, Q also, you have to see D also. So based on both Q and D, final experimental value CH3Cl is the winner over CH3F. If you only give the priority of charge, then fluorine is getting more delta minus compared to chlorine, because it's more electronegative. Got it? But you have to give here priority with respect of both charge and distance, and this is the winner. But same dipole moment is not going to take place in case of H. Here fluorine is the winner, then chlorine is the winner, then bromine, then iodine. Hope you understand. That's why I am giving together two examples so that you can understand always charge is not the winner, always distance is not the winner. Okay, if you see only distance, then this is the highest distance, iodine is bigger in size. If you see only charge, here charge is the priority, here distance and charge overall. At the end you have to go for experimental dipole moment value. Okay, let's go for some more molecule. If I take methane and I keep replacing that one by one chlorine, let's see what will happen. Methane, first of all, methane is 0. Okay, they are tetrahedral. Methyl chloride, CH3Cl, then CH2Cl2, dichloromethane, then CHCl3, chloroform, then CCl4. Okay, so hope you understand these things are important. I will give some different molecule for dipole moment later on, but from till now you have to understand this concept, and whatever I was talking about, if their nature is same, then only you can use this formula, otherwise you have to go for resultant dipole moment vector. Okay, thank you for watching, and do share with your friends so that I can make more and more videos.